Okay, in this next section, we're looking at something called the expected values of discrete random variables. And we're also looking at variance and standard deviation. Okay, so expected value is the long-term average or mean. All right, so that really is, when we hear expected value, we're just finding an average. We're just finding a mean. So this means that over the long term of doing an experiment over and over, you would expect to get this average or this mean. So that's where that word expected comes from. That's why we have kind of a different terminology. So we're thinking about over the long haul, if we repeat something over and over and we took the average of the outcome or the random variable that's associated with the outcomes, then we would get this expected value. All right, so let's take a really simple experiment and a really simple random variable. It's just equal, well, the experiment is rolling a 6-sided fair die, and the random variable equals the value that results when we roll that die. And we want to figure out what is the average value of x if the die is rolled many, many times. Well, we can list out the values that x takes on. 1, 2, 3, 4, 5, 6. And we know that each of these values is equally likely to occur. So to find the mean, or the expected value, we just need to find the mean of those 6 values. So add together the 6 values that the random variable can take on, divide by the total number, and we get the expected value is 3.5. So if we rolled a die many, many times and we recorded the result each time, and then we took the average, we would expect that that average would be 3.5. So notice that that 3.5 isn't an actual value that x can take on. Okay, so the expected value is really like an average or a mean. It doesn't have to actually equal a value that the random variable can take on. Okay, so that is a case where we've got equally likely outcomes or equally likely values or equally likely probabilities for the values of the random variables. So yes, equally likely outcomes. Okay, that's not always the case. And, oops, sorry about that. So let's look at where, like the example before, where we looked at the random variable that counted the number of tails when 3 coins are flipped many times. Okay. We have the values of x, and they have different probabilities associated with them. Okay, they're not equally likely. Okay, 0 and 3 have a probability of 1/8, and 2 and 3 have that, or 1 and 2 have that probability of 3/8. So when we have outcomes or random variable values that do not have the same probability, we are going to calculate expected value like this. Okay, it looks more complicated than it is. We are basically going to take the value that x is and multiply it by its probability, and then sum those all together. So the expected value really is a weighted mean of x, where the weights are the probabilities. So we're going to, we can create another column up here where we multiply x times its associated probability. So we'll get 0 and then 3/8, 6/8, and another 3/8. So if we add those up, we end up with 12/8, which is equal to 1.5. Okay, so if we flipped 3 coins many, many, many times, and each time we recorded the number of tails, if we took the average of those values, we would expect to get 1.5. Okay. So that is how we calculate an expected value for a discrete random variable. We multiply the value and the probability and then sum them up. All right, so let's look at this other example we've been working with. We've got values of x. They have different probabilities. So to find the expected value, we first want to multiply those values by their probability. So we'll get 2, 3.3, 2.4, 1.3, and 2.8. All right, and then adding that column is going to be what gives us the expected value, or the mean of this random variable. So adding those up, you get an 11.8. And then I'm going to go back to this page and look at, on this page, because I actually have the columns all set up for it. So we are going to look at taking the values of x, subtracting that mean value that we found of 11.8, squaring it, and then multiplying it by the probability. And we do that for each value of x. So I'm going to make that bigger. So first one, we have the value 10 minus 11.8, square that, multiply by 0.2, and that gives us 0.648. And then we take the next value, 11 minus 11.8, square that, multiply by the probability of 0.3. 0.3, and that gives us a value of 0.192. All right, then we've got 12 minus 11.8, squaring that, multiplied by the probability of 0.2, you get 0.008, and then 13 minus 11.8, square that, multiply by the probability of 0.1, and that gives us a 0.144. And then finally 14 minus the mean of 11.8, square that, multiply by the probability of 0.2, and that's a 0.968. Okay, so if we sum that column up, that's going to give us variance. So adding those up, we get 1.96 for the variance. Then to get standard deviation, we take the square root of that, and we get 1.4. Okay, if you want to do some more examples of finding expected value, then go ahead and go back to 4.1 and do find expected values for those PDF tables that we came up with. And at the end of this lecture, I'll give you the answer so you can check your work. Okay, so let's look at variance and standard deviation of a random variable. So we did expected value, which is a mean, that measure of center. Now we want to look at the measure of variability for a discrete random variable. So just like a standard deviation for a data value is the average distance away the data values are from the mean, we can also think of the standard deviation as being sort of the average distance away of a value that the random variable takes on from the mean. Okay, so we're going to measure variability as the average of the squared distance of x away from the mean. Okay, so that shows up in the formula here for variance. We're taking the difference between x and the mean, we're squaring it, multiplying that by the probability, and then adding those up. Okay, let's look at this example where we had the x equaling the values 10, 11, 12, 13, 14. Okay, again, you can practice standard deviation and variance or variance and standard deviation using those examples from 4.1. And at the end, I'll give you what those answers should be. Now, let's look at a couple more examples. We're just going to kind of start from scratch and go through the whole process where we want to come up with a PDF. We want to come up with a expected value. And I think for these, we're going to skip variance and standard deviation. A friend offers you the following deal. For a $10 fee, you may pick an envelope from a box containing 100 seemingly identical envelopes. However, each envelope contains a coupon for a free gift. Okay, then it describes the type of coupons that are included in those 100 envelopes. So based upon the financial gain or loss over the long run, should you play this game? So first thing we want to do is kind of identify, well, what's the random variable here? What is varying from, what's varying from outcome to outcome? Well, it's going to be your gain or loss in playing this game over time. So we want to come up with the values for the gain or the loss, and these are going to be based on basically what envelope is picked. So this first one, 10 of the coupons are for a free gift worth $6. So we get $6, but we had to pay 10 to play. So we have a -4. And then the probability associated with the -4 is 10 out of 100, because there's 10 that are going to have $6. So 10 out of 100, or 0.1. All right, look at the next type. There's 80 of the coupons are free gift worth $8. So we get $8, but we had to pay 10, so we have -2. And there's 80 of those, so we got 80 over 100, or 80.8 for the probability. The third type, 6 of the coupons are for a free gift worth $12. So finally, all right, we're going to actually gain, and we have a gain of $2. There's 6 of those. So 6 over 100, so 0.06. And then finally, 4 of the coupons are for a free gift worth $40. So we get 40, we had to pay the 10, so net gain of $30. And the probability there is 4 out of 100, or 0.04. All right, so there's our PDF. We have the values that X can take on, -4, -2, +2, and 30, and their associated probabilities. And we can just do a quick check, make sure those add up to 1. So 0.1 plus 0.8, we get 0.9, plus 0.06, we get 0.96, plus 0.04. We do indeed get a total of 1. All right, let's now find the expected value. So we're going to take X times the associated probability. So -4 times -4 times 0.1, so we get -0.4. -2 times 0.8 is a -1.6. 2 times 0.06 is a 0.12. And 30 times 0.04 is 1.2. Okay, so kind of the question here is, are we going to end up in the hole, or are we going to end up making some money? If we add all these up, we end up with mean, all right, which is the sum of this column. Just remind ourselves what we're doing, is a -0.32. So over the long haul, if we keep playing this, we're going to be in the hole. We can expect to be in the hole 0.32 cents, 32 cents. Okay, another example. A physics professor wants to know what % of physics majors will spend the next several years doing postgraduate research. He has the following probability distribution. So number 1, find the probability that a physics major will do postgraduate research for 4 years. So that is the one that is missing from the table. So we need to add up the probabilities that are there, and then subtract that from 1, and it'll give us the probability that x is equal to 4. Okay. So if we add those up, we're going to get 0.85. So the probability that x equals 4 is 0.15. All right, we can plug that in. Now our probability column will add up to 1. Now find the probability that a physics major will do postgraduate research for at most 3 years. So that's the probability that x is less than or equal to 3. So that at most, all right, that goes with less than or equal to. We want to include the 3 years, and we want to include everything less than it. All right, so adding up those probabilities, 0.35 plus 0.2, plus 0.15, you get 0.7. Okay. On average, how many years would you expect a physics major to spend doing postgraduate research? So this doesn't come out and say find the mean or find the expected value, but hopefully you're noticing this word expect in there, and also it says average as well. So what this is asking for is find the expected value of x. So expected value of x. So let's go back up to our table, and let's create this new column, x times associated probability. So we get 0.35, 0.4, 0.45, 0.6, 0.5, and 0.3. All right, so adding those up is going to be what gives us the expected value. And if we add those up, we're going to get a 2.6. So because it's a mean, we can also label it. So on average, we can expect a physics major to spend 2.6 years doing post-grad research.